meter pan rating of 325 amps is typically the maximum amperage that can be safely passed through the meter itself. This rating is separate from the rating of the meter pan as a whole. The meter pan is designed to handle the amperage of the service that it is supplying. In this case, the meter pan is rated for 400 amps. This means that the meter pan can safely handle the load of a 400 amp service. The meter itself is rated for a lower amperage 325 amps in this case. This means that the meter is not designed to handle the full amperage of a 400 amp service. The service rating is determined by the size of the conductors and equipment used in the service. In this case, the service conductors are sized for 400 amps and the disconnects and subpanels are also rated for 200 amps. Therefore, the service is rated for 400 amps. The discrepancy between the meter pan rating and the meter rating is likely due to the fact that the meter pan is designed to handle the load of a 400 amp service, while the meter itself is not. This is a common practice by utility companies to ensure that the meter does not overheat or become damaged. In order to comply with the meter rating, the main breakers in the subpanels would need to be downsized to 150 amps each. This would reduce the overall service rating to 300 amps. To avoid this situation in the future, it is important to communicate with the utility company before installing a service that exceeds the rating of the meter pan that they will be supplying. The utility company can provide guidance on the appropriate meter and meter pan for the desired service rating. Understanding these ratings is crucial for ensuring a safe and compliant electrical installation. When upgrading an electrical service, several factors must be carefully considered to ensure both safety and compliance with local codes and regulations. The amperage ratings of the meter pan, the meter itself, and the overall service are all critical components that need to be properly understood and coordinated. Firstly, the meter pan rating signifies the maximum amperage the pan is designed to handle safely. This rating is often distinct from the amperage rating of the meter that is installed within the pan. Secondly, the meter itself has a maximum amperage rating, indicating the highest current it can accurately measure without sustaining damage. Thirdly, the overall service rating is determined by the capacity of the conductors, disconnects, and other equipment in the service. Discrepancies can arise when the meter pan is rated for a higher amperage than the meter itself. This situation is not uncommon, as utility companies may use a standard meter pan designed to accommodate a range of service sizes while using meters rated for specific amperage levels. In these cases, it's essential to ensure that the meter's amperage rating is not exceeded, even if the meter pan is capable of handling a higher current. To address discrepancies between the meter pan and meter ratings, it may be necessary to adjust the size of the main breakers in the subpanels. If the meter is rated for 325 amps and the service is intended to be 400 amps, downsizing the main breakers to a combined total of 325 amps or less would be necessary to comply with the meter's limitation. This reduction in breaker size would effectively limit the overall service capacity to match the meter's rating. Before commencing any electrical service upgrade, it is imperative to consult with the local utility company. Utility companies can provide valuable guidance on the appropriate meter and meter pan for the desired service rating. They can also clarify any specific requirements or limitations in their service territory. This proactive communication can help prevent misunderstandings and ensure that the installation meets all necessary standards. In addition to consulting with the utility company, it is also essential to verify compliance with the National Electrical Code and any local amendments. The NEC provides comprehensive guidelines for electrical installations, including requirements for service sizing, conductor ampacity, and overcurrent protection. Familiarizing oneself with these requirements is crucial for ensuring a safe and code-compliant installation. Consider a scenario where a residential customer desires to upgrade their electrical service from 200 amps to 400 amps to accommodate additional electrical loads such as a new air conditioning system, electric vehicle charger, or expanded kitchen appliances. The electrician performs the necessary calculations and determines that a 400 amp service is required to meet the customer's needs. They install 500 kc mil copper conductors from the utility transformer to a new 400 amp meter pan. The meter pan is then connected to two 200 amp disconnects, each feeding a 200 amp subpanel inside the house. During the installation, the electrician notices a label on the meter pan stating 325 amp maximum meter only. This label raises a question about whether the meter itself is capable of handling the full 400 amp service. Upon further investigation, the electrician confirms that the meter provided by the utility company is indeed rated for a maximum of 325 amps. This discrepancy between the meter pan rating and the meter rating presents a challenge. The electrician cannot simply ignore the meter's rating, as it is a critical component of the electrical system. Overloading the meter could lead to overheating, damage, or even failure. To address this situation, the electrician has a few options. Firstly, they could contact the utility company to request a meter with a higher amperage rating. If the utility company can provide a 400 amp meter, the electrician can proceed with the installation as planned. Secondly, the electrician could downsize the main breakers in the subpanels to comply with the meter's 325 amp rating. This would involve replacing the two 200 amp breakers with two 162.5 amp breakers. However, this option would reduce the overall service capacity to 325 amps, which may not be sufficient to meet the customer's needs. Thirdly, the electrician could explore alternative service configurations. For example, they could install two separate 200 amp services, each with its own meter and meter pan. This option would require additional coordination with the utility company, but it could provide the necessary capacity without exceeding the meter's rating. In any case, it is essential for the electrician to communicate with the customer about the situation and explain the available options. The customer needs to understand the implications of each option and make an informed decision about how to proceed. It is also important to document all communications and decisions in writing. This documentation can be helpful in resolving any disputes that may arise later. In addition to the amperage ratings of the meter pan and meter, it is also important to consider the voltage rating of the service. The voltage rating indicates the maximum voltage that the service is designed to handle. In North America, residential services are typically rated for 120/240 volts. This means that the service can provide both 120 volt and 240 volt power. 120 volt power is used for lighting small appliances and most electronic devices. 240 volt power is used for large appliances such as air conditioners, electric water heaters, and electric stoves. When upgrading an electrical service, it is important to ensure that the voltage rating of the new service is compatible with the existing electrical system. If the voltage rating is not compatible, it may be necessary to replace some of the existing electrical equipment. Another important consideration when upgrading an electrical service is the grounding system. The grounding system is designed to protect people from electric shock by providing a path for fault current to flow back to the source. A properly installed grounding system is essential for electrical safety. While upgrading an electrical service, it is important to ensure that the grounding system is properly installed and maintained. This includes grounding the meter pan, the service disconnect, and all subpanels. It is also important to bond all metal enclosures and equipment to the grounding system. Bonding is the process of connecting metal parts together to create a low impedance path for fault current. Bonding helps to ensure that all metal parts are at the same voltage potential, which reduces the risk of electric shock. In addition to grounding and bonding, it is also important to provide overcurrent protection for the electrical service. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When an overcurrent occurs, the overcurrent protection device will trip, interrupting the flow of electricity and preventing damage to the electrical system. When upgrading an electrical service, it is important to ensure that the overcurrent protection devices are properly sized and installed. The size of the overcurrent protection device should be based on the ampacity of the conductors that it is protecting. The ampacity of a conductor is the maximum current that the conductor can safely carry without overheating. The NEC provides tables that list the ampacity of different types of conductors. When selecting overcurrent protection devices, it is important to choose devices that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or Intertek. Listed and labeled devices have been tested to meet safety standards and are suitable for use in electrical systems. In addition to the technical aspects of upgrading an electrical service, it is also important to consider the permitting process. Most jurisdictions require a permit before any electrical work can be performed. The permit process typically involves submitting plans and specifications to the local building department for a review. The building department will review the plans to ensure that they comply with the NEC and local codes. Once the plans are approved, the building department will issue a permit. The permit allows the electrician to perform the electrical work. After the electrical work is completed, the building department will conduct an inspection to ensure that the work was performed in accordance with the approved plans and the NEC. If the inspection is successful, the building department will issue a certificate of occupancy. This certificate of occupancy allows the building to be occupied. Upgrading an electrical service can be a complex and challenging task. It is important to hire a qualified and licensed electrician to perform the work. A qualified electrician will have the knowledge and experience to ensure that the electrical service is upgraded safely and in accordance with the NEC and local codes. Here's an expanded discussion of meter pan and meter ratings along with practical examples and code considerations to provide a more thorough understanding. Firstly, let's consider meter pan ratings in detail. The meter pan, also known as a meter socket, is the enclosure that houses the electric meter. It's designed to physically support the meter and provide a secure connection point for the service conductors. The meter pan rating indicates the maximum continuous current the pan's terminals and internal components can safely handle. This rating is crucial to prevent overheating and potential fire hazards. Typically, meter pans are rated for common service sizes such as 100 amps, 200 amps, 325 amps, or 400 amps. The rating is usually marked on the meter pan enclosure. It's important to note that the meter pan rating refers to the pan itself and not necessarily the meter installed within it. Secondly, we should discuss meter ratings. The electric meter measures the amount of electrical energy consumed by the customer. Like the meter pan, the meter itself has a maximum current rating. This rating indicates the highest continuous current the meter can accurately measure without damage or malfunction. Meter ratings are typically expressed in amps. For example, a meter might be rated for 200 amps, meaning it can accurately measure currents up to 200 amps continuously. Exceeding the meter's rating can lead to inaccurate readings, meter damage, or even failure. The utility company usually selects and installs the meter based on the expected load of the service. Now let's discuss the discrepancies that can arise. A common issue occurs when the meter pan is rated for a higher amperage than the meter installed within it. For example, a 400 amp meter pan might be used with a 325 amp meter. This situation is not necessarily a code violation, but it requires careful consideration. The service must be designed and protected so that the meter's rating is never exceeded. In cases where the meter pan rating is higher than the meter rating, the overcurrent protection e.g. circuit breakers must be sized to protect the meter. This means the main breaker or breakers feeding the service should have a combined rating no higher than the meter's amperage rating. This ensures that the meter is never subjected to current exceeding its capacity. Let's consider some practical examples. Suppose a homeowner upgrades their service to 400 amps, and the utility company installs a 325 amp meter in a 400 amp meter pan. To comply with the meter's rating, the electrician must install main breakers that limit the total current to 325 amps or less. This could be achieved with two 162.5 amp breakers in a split bus panel configuration, or a single 325 amp main breaker. Another example could be a commercial building with a 600 amp service. The utility company installs a 400 amp meter in a 600 amp meter pan. In this case, the main overcurrent protection must be sized at 400 amps or less to protect the meter. The remaining 200 amps of capacity in the meter pan cannot be utilized without replacing the meter with a higher rated unit. Code considerations are also important. The National Electrical Code (NEC) provides guidelines for service sizing and overcurrent protection. While the NEC doesn't explicitly address the situation where the meter pan rating is higher than the meter rating, it does emphasize the importance of protecting all electrical equipment from overcurrent. NEC Section 230.90 requires that service overcurrent protection be provided in each ungrounded conductor. The rating of the overcurrent device must not exceed the ampacity of the service conductors or the equipment they supply. This requirement indirectly addresses the meter rating issue, as the overcurrent protection must be sized to protect the meter even if the service conductors and meter pan are rated for a higher amperage. Communication with the utility company is essential. Before installing or upgrading an electrical service, it's crucial to communicate with the local utility company. The utility company can provide information about the available meter sizes and any specific requirements for their service territory. They can also advise on the appropriate meter pan and overcurrent protection for the desired service capacity. Additionally, documentation is key. Keep detailed records of all communications with the utility company, as well as the ratings of the meter pan, meter, and overcurrent protection devices. This documentation can be helpful in resolving any disputes or misunderstandings that may arise during the installation or inspection process. In summary, understanding the meter pan and meter ratings is crucial for designing and installing a safe and compliant electrical service. When the meter pan rating is higher than the meter rating, it's essential to size the overcurrent protection to protect the meter. Communication with the utility company and thorough documentation are also important steps to ensure successful installation.